Hello viewers, today I'm going to talk about physics paper 510/2, and majorly I'm talking about capacitors. Under this I'm going to talk about capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. So my name is Mundeya Andrew, a steady man. So when you look at capacitance of a parallel plate capacitor, so I want to derive the expression for capacitance of a parallel plate capacitor. We said that capacitance of a capacitor refers to the ratio of magnitude of charge on either place of the capacitor to the PD between the same capacitor plates. Assuming that this is my first plate of the capacitor, and then this is another capacitor plate, and then there is a PD applied between these capacitors, a PD a PDV applied. So this is plate A and this is plate B. Those plates are each of cross-sectional area, capital A, and let V be the PD across the plates, and then let small d be the plate separation, which means that it is this distance separating the plates A and B. So if I want to determine the capacitance of that parallel plate capacitor, I'm going to recall from the expression of electric field intensity. Electric field intensity, capital E, is equal to the PD across the plates divided by the plate separation. Electric field intensity, capital E, is the ratio of the PD across the plates to the plate separation. We call this one equation 1. Then from Gauss's law, we see that also electric field intensity is equals to charge density over permittivity. Permittivity means how strongly a given medium can be polarized, and permittivity is represented by this sign epsilon, and therefore electric field intensity is equals to charge density, which is that divided by permittivity. But charge density is the same as charge over the of the area, and therefore electric field intensity, capital E, equals to Q over A epsilon. If the medium between these two capacitor plates is air, and therefore this permittivity becomes permittivity naught, or epsilon naught, and call this one equation 2. Equating equation 1 and equation 2, since they are both electric field intensities, I'm going to have V over D same as Q over A epsilon naught. Remember that the capacitance of the capacitor is the ratio of magnitude of charge on either place of the capacitor to the PD between the same capacitor plates, and therefore if I make Q over V the subject, I'm going to get the expression of capacitance of the capacitor, and therefore if I say A times epsilon naught over D is equal to Q over V, this is similar to this, but Q over V is the same as C, and therefore C is the same as A epsilon naught over D, and this is the expression of capacitance of a parallel plate capacitor. Members, after knowing how to derive, of course it is crucial to know the derivation of capacitance of a parallel plate parallel capacitor. So this value of epsilon naught, it is a constant, and it is always 8.85 exponent negative 12. So this is the expression of permittivity of free space. There are various questions. How can they twist these questions? Like in UNEB, in old curriculum, we saw UNEB asking this question in 2001. We also saw the question in 2001, 2002, which is and also recent we saw in 2020. These questions here are somehow directed. Automatically, they can give you the area of the plates. They give you the distance of separation. Permittivity is a constant. They want you to determine the capacitance of that plate capacitor. Or if they are too tricky, they can give you that is the first question. They can give you the two variables and one unknown. For example, we have 1, 2, 3 variables, because this one is a constant, it's not varying. So if they give me A and D, I can get C. If they give me C and A, I can get what? D. If they give me D and C, I can get what? A. Now there's this tendency, because I know that C is equal to Q over V, there's a this tendency of them asking again for me to determine the charge. When they are giving me the PD across the plates, they have also given me the cross-sectional area, and they have also given me the plate separation. So I am going to replace from this expression of C is equal to epsilon naught A over D, where the C are replaced with Q over V. This one give me epsilon naught A over D, and so I can make Q the subject. So Q is equal to epsilon A times V over D, and that is the expression. The same way is true if they want me to get the PD. And so if I want to get the PD, then PD is the same as QD or epsilon naught A. And so the examiner should provide for me the charge, distance, and the area. And therefore, those are the calculations. They are never twisted. I just need to identify what the examiner has given me. This form here is now the twisted form if they want charge. So I have to know that capacitance is also charge over what? Or voltage. And that is all about the derivation of a parallel capacitor. And these questions here, you should answer them. You choose the questions, the Romans which particularly correspond to this content. Then you send the answers. I pass through them. So when going further there, we want to look at the factors affecting the capacitance. Factors affecting the capacitance. Factors affecting the capacitance of a parallel plate capacitor. Factors affecting the capacitance of a parallel plate capacitor. So from this expression of capacitance of a parallel plate capacitor, you realize that capacitance C is equal to summation of A over D, where this summation is the same as permittivity of the medium. Last time we said that permittivity means how strongly a given medium can get polarized. You know, polarization means that you are creating positive and negative charges, and therefore capacitance is equal to permittivity A over D. So these are the very factors affecting capacitance of a parallel plate capacitor. One of them is permittivity of the medium between the capacitor plates. 2 is the cross-sectional area of the capacitor plates. And then 3 is the distance of separation. So when I look at the permittivity of a medium, so I'm going to consider 2 plates. So let me start with the distance of separation. And if I'm to explain these factors, I should always make the other 2 factors constant. If I'm explaining distance, then permittivity and A should